Okay, here we are in Knife River, and we're in the woods by the railroad tracks at an old broken down platform. And I was fishing around here and I found their old flag. And the idea was, which is all kind of falling apart, the idea was, back 100 years ago, if you wanted a ride from the train, you'd go out on the platform. This thing doesn't collapse under me. With the flag that was rolled up in a tube that you took out, and you flag down the train. We call this a sentinel. And this is the reason I mention it is because it's exactly the way you stop a while loop. We talk about while loops being sentinel, having sentinel values to control them. So a single value stops the train, stops the while loop from executing. Anyway, I thought it would be kind of cool. It's really amazing old artifact out in the woods along the train track. Okay. Okay, today we're going to conduct our review of control structures. As you'll remember, we've got an outline of these things. Sequential control structures, you don't skip any, you don't repeat any, you just do everything in order. Branching structures allow you to skip statements, we have a variety of those, and loops allow you to repeat statements, and we have a variety of those. Each of these things, the if statements, the switch statement, the while, the do while, the for, are like tools in a programmer's toolbox. Whenever you go to a job, you sit down and you decide, what do I need to solve it? Sometimes you need repetition, sometimes you need selection, sometimes you need combinations of both. If we know how to use these tools well, we can write code to solve any problem. In fact, knowing the control structures is the reason why we have this first third of the course. That's the dominant outcome that we should get here. Everybody should know how to use these tools because we'll need them all semester long for everything we do. So let's do a quick review of these things and see if we can figure out how they might come into play in various situations. You can think about algorithms here and you can think about code. It's easiest to think about algorithms and then to discuss what kind of code might come from it. So here's a sample problem. Write a program to add up the sum of a bunch of negative numbers. There won't be more than 10 of them. Okay. Consider what control structures you might need for this. You know you're going to need a loop because there's repetition. You're adding up a bunch of things. You don't seem to know how many there are actually going to be, but you know there won't be more than 10. So somehow you have to keep a count going. And if the number is not negative, well then you've got to do something with that too. So we have a bunch of things to sort out. Here's one way that you might do it. Tell the user to enter 10 negative numbers and then read the first one. You've got a count variable set up that's set to 0 as long as the count is less than 10 and the number you read is less than 0, it's good. You can process it, add it to the sum, you can read the next one. And so this while loop takes us through a process of reading numbers over and over and over and over again. Notice at the bottom of the loop we're adding 1 to a counter each time, so we're counting each of the iterations. As long as the count is less than 10 and the number that you just read is less than 0, it's good, we can process it. So that's kind of what we're shooting for. There are some very common uses for loops especially that we should be familiar with. Summation, finding the largest and the smallest, counting the number of occurrences of a value or an event. So let's just quickly go through those. Summation we kind of already did in detail with for loops. Basically, a for loop just runs from a low to a high value and adds up a bunch of numbers. So summation, I think we should probably have already. Finding the largest, consider this situation. Here we have a loop that's going to run with I going from 0 to less than n. So if n is 10, the loop goes from 0 to 9. You want to find the largest of 10 values, run a loop that goes 10 times. And then compare values. Compare a number to what the largest value is so far, and if that number is greater than the largest, then put it in. And then read the next number. That seems to be a good strategy for this. The only problem here is that num and large were declared at the top and they're undefined, and if we leave this like it is, the first time we get to the if statement inside the loop, num and large won't be set to anything, and so we'll have a big problem there. So we should read the first number, set that up as the largest, the one to beat, and then continue from there. Having read the first, we don't need to read 10 items now in the loop. We only need to go 9 times. And so you can see I altered the upper bound here to n minus 1 instead of n. And so that helps us go just 9 times. And then we're good. We read a number inside the loop, we see if it's greater than the largest, and if it is, we put it in. Then we go back around and read the next number, and the next number, and next number, and so on. To find the smallest is a minor change here. We're reading data values. We're setting it up, putting one into the smallest value. Inside the loop, we're reading values, and if the number is less than small, we're putting it in there. It's the same process, just going low instead of high. Now, if you don't know how many integers you're going to get, and in the last 2 examples you saw we had 10 integers, if you don't know how many of them there are going to be, you have to work a little differently. You can't use a for loop. For loops count. They're counter-controlled loops. So if you know you're going to have 10 numbers, you count up to 10 and we process each one. With a while loop, if you don't know how many values are coming in, use the while loop and run it until you hit a condition that tells you to leave. In this case, we want to find the smallest of an unknown number of positive integers. Okay, so when they type in a negative value or 0, then that's time to leave. And that's the way our while loop is set up. As long as you're giving me data that's greater than 0, fine. We can process it. I'll check it out, see if the number is less than the smallest, and if it is, it becomes the smallest. And then I'll read the next one. So we process the data and then read the next, and then process the data and read the next, and so on. So your choices for these next few things are going to be as follows. A while loop is choice A, a do while is B, a for loop is C, and if the problem doesn't require a loop at all, then D is the right answer. So let's just do a little checkup thing here. Imagine you're going to drop an object from a building onto a sidewalk. You want to write a program that prints the height of the object after each second until it strikes the ground. Which of those control structures do you need? What's the dominant control structure for this program? Think about that for a second. You can pause it if you want, then come back and we'll look at some code. Here are your choices: while loop, do while loop, for loop, if statements. Here's the code, and notice this is a while loop problem. It's a little tricky, but it's a while loop problem because you don't know the height that this object is going to be dropped from. And depending upon the height, the number of seconds could differ quite a bit. So you ask the user for the height, and then the loop runs by calculating a new height after every second until you hit the ground. So as long as the new height is greater than 0, then you can calculate the next new height as this thing falls. So this one kind of seems like a for loop problem, but it's really not. It's a while loop problem. Drop the object from a certain height and continue counting seconds until it hits the ground, whenever that might be. Okay, here's another one. A factory produces items that have to be within 5 to 10 centimeters of width. Write a program that reads the width of each item and displays a message if it's not in the 5 to 10 centimeter range. There are your choices again. See if you can figure out which one you need to solve this, and then when you're ready, go on. And here's the code for this. I didn't tell you how many items you had to process. It's just a factory and a bunch of stuff is coming off the conveyor belt, and you're just, okay, in a situation like that, you just have to set up a loop that will run as much as it needs to, and that's going to be a while loop. Since we don't know the end, we can't count our way there, we just start reading the width of each item. So you read a width, as long as the width is greater than 0, it's a positive number, then you process it. How do you process it? You check and see if it's in the proper range. If it's less than 5 or greater than 10, then you print out an error message. And then you get the next width. And process one width after the next after the next. In this example, we're going to write a program that asks the user for two integers and counts all the prime numbers that occur between them. And you can assume that there's a function called isPrime. There isn't, but you can assume that there is one of these that will tell you whether a value is a prime number or not. Consider which type of loop you might need to have to solve this problem. Then come back. Okay. This is one that is a for loop because we know where we're starting, we know where we're finishing, and we're going up by ones. This is a counter-controlled problem. Ask the user for the low and the high. Set up your loop control variable so I starts at low and goes up to high. And then one by one, check and see if I is a prime number, and if it is, add one to a count. Write a program to make a multiplication table. Okay, this one is going to be a tough one because this one is definitely going to need more than one loop. In fact, this one needs nested loops. So I'll give you that right away. But what type of loops? And the answer here is this is a for loop problem. We're counter controlled. Here's an example of a smaller multiplication table. It goes from 0 to 9 down the rows and across the columns at the top, and then gives you the calculations. The thing to remember with this is you're going to need one loop to identify which row you're on, and then within each row another loop to take you across the columns. And we do that with nested loops. You can see them down below here in the for loops at the bottom. The outer loop with I as a loop control variable tells you which row you're on. The inner loop with j as a loop control variable tells you which column you're on, and then we're just printing out I times j. The set W business that you see here just sets the width so that we get nice even columns. Write a program to find the largest of three integers. Well, we know about this. We've done this in the past. This should not be all that difficult. It's not a loop problem at all. It involves if statements. We're given three numbers and we just have to sort them out. Okay, if num1 is greater than num2, or num1 is greater than num3, and so on. The easy way is with logical operators. If num1 is greater than num2 and num1 is greater than num3, then num1 is the largest. But you should try to solve this without logical operators and see if you can do it. That will involve nesting, nested control structures, nested if statements, and it's a little more of a brain teaser. Okay, so that's a review and a bunch of problems you might try to solve and see if you can sort out on your own. Go on to Janus, do those as best you can, just to kind of sharpen your claws here, getting ready for the exam that comes up. Okay, thanks for watching. I can flag down the train with my shirt, I suppose, but I don't think they